There are many impressive and eye-catching renewable developments happening. The race to build the biggest turbine or the most original way to repurpose blades. New big offshore energy hubs or hybrid and PTX plants. These are all visible to us. But what about the behind the scenes? Who is controlling the energy? And what challenges do they face when sitting in a control room of a renewable plant? Hi, and welcome to Energy Explained in Short, where we discuss all things energy and more specifically renewable energy. In these In Short series, we will tackle a topic and have a discussion, so you get the bigger picture in a small format. Today, we submerge ourselves a bit deeper into control room challenges in energy and especially renewable energy plants. We are traveling to unseen spaces today, spaces that are working behind the scenes. Control rooms. So let's start with the basics. What are control rooms? Control rooms serve as essential components of power stations, and they are tasked with overseeing the safe and efficient operation of the facility. So they are responsible for managing all aspects of the power station's operations, which can include monitoring and regulating electricity generation, but also implementing emergency protocols when necessary. But, okay, what do you think of when we talk about control rooms? How does this space look like? In our minds, when we think of a control room, we think of a countdown to launching a new spaceship into the next mission. Or maybe a TV control room instead, where panic surfaces every time a live connection with an international correspondent fails. Or instead, we may often think of an apocalyptic or utopian film where the control room is full of heroes that will save the day. All these scenarios have one thing in common, and that is the basis of the concept of a control room. It's where the mind and the heart of monitoring and management practices takes place. However, in real life, it may not be as exciting or a life-death situation like in the movies. It can still be nerve-wracking and stressful though. Because the control room of a power station is the central hub for overseeing the entire facility. And tiny mistakes can have great consequences when it comes to energy production and the balance of the grid. To have that kind of responsibility is never an easy job, but renewables might actually make it harder. By now, you may have heard us say this multiple times, but renewables are fluctuating energy sources, which means that we can't switch them on and off whenever we want. So, how exactly does this lack of control affect the control room? We talk about it today in the discussion. For this episode, though, we have slightly different discussion partners. Our co-host Christine Landgreve and our guest Nick Hess talked about this at the Clean Power Fair. Take a listen to what they have to say.
Hi everyone, I'm here at Clean Power today with my good colleague Nick Hess, Key Account Manager at SCADA International. Thanks for joining, Nick.
You're welcome, man. Excited to be here.
So now we're sitting here on the last day of the fair in Minneapolis. How would you say it's been so far?
Yeah, it's been really nice to learn about new technologies, especially in the battery space and in the solar space. We've had a lot of time to connect with old colleagues as well, and some of our customers, so it's been nice to make those connections in person.
Cool. And we're here today to discuss control room challenges in the renewable energy sector. Is this something that you also seen has been a topic in the last few days?
Yeah, it's something that quite a few people are asking about. They're wondering how they can scale their operations and how they can do that efficiently.
Cool. And we've hijacked you for this interview because you actually reached out to us saying, hey, do you know what could be relevant for you to dig a little bit deeper into? Control room challenges. But why is that? What's your personal experience with control rooms?
I worked at an OEM, managing a control room for 7 years, growing it from just a small 6-person team to 17 people, and
Wow.
and when I left, having 15,000 turbines and 35 gigawatts under control. So have spent some time in a control room. I think they're interesting environments that don't often...
And how's the environment? What does it feel like?
Yeah, the environment can change. There's an ebb and flow to it depending on what is happening in the operations, but typically it's a calm, quiet environment.
Oh, really?
Yeah. It's, I would say, very controlled, and we try to keep that feeling very simple and peaceful for those serious moments where more action and focus are needed.
Because when I actually think of a control room, I imagine something much more chaotic. Alarms going off everywhere, people trying to solve emergencies, but you're saying it's much more quiet, it's much more controlled?
Yeah, when there is a lot of chaos, humans or people are not responding well in those situations. And so if we can make the environment much more simple, much more peaceful, it's easier to respond with logic and with sense.
So in what ways does the renewable power plant adapt to these new fluctuations and the change we see in the, with renewable energy sources, changing weather patterns or variations in solar and wind availability? It must have been more difficult.
Yeah. With renewables, we have this variability in the weather where where the operations of the power plant fluctuate and change as the weather changes, whether that is a cold day versus a hot day, whether there's precipitation happening. So there's many different variables that can influence the operation of the power plant. That can also drive the event activity with those individual turbine generators or solar inverters, whatever it may be. And those drive alarms. So those alarms are becoming active to protect the equipment, and that's where control room operators step in.
And what are the challenges that arise from having to control a renewable power plant? What are the main challenges you see at the moment?
Yeah, with a conventional power plant, you have a single or maybe a few large generators. With a renewable power plant, you have many different generators, many different pieces of equipment that can fault and go down. So you have almost an exponential challenge in trying to control those when situations arise.
Yeah, so I guess there's also what you're saying, it's much more exponential. There's much more data integration that you also need to take into account.
Yeah, there's many different data points. If we consider wind turbines, for example, you could have hundreds, if not thousands, of data points coming in for a single unit, and then when you add 200 turbines possibly at some of these larger sites, that's a lot of data points to take in and analyze.
And how do you manage that as a person working in a control room operator?
Yeah. A control room operator typically has multiple screens in front of them. They have the SCADA system itself that they're reviewing and looking for faults and trying to decipher which actions are needed to be taken. So they will make informed decisions on reviewing protocols, reviewing the SCADA data that's coming in, and then from all of that information that they have, they'll decide if it's safe to take an action on the turbine or if they need to dispatch a local team.
So they need reliable data in order to do their job?
Yeah, absolutely.
Oh.
Yes.
And what are some of these key parameters and metrics that you monitor regularly in the control room?
The control room metrics are typically how quickly can a control room operator respond to a fault. So that's measured to understand the efficiency of response for certain alarms. It could also be the success of resetting those alarms, so looking at how successful the protocols are, how successful the individuals are in resetting those alarms, with the ultimate goal to reduce downtime at the wind farm to improve the availability and the energy production.
Yeah, to ensure efficient operations and optimization, basically.
Yeah, absolutely. If we look at the operations of the wind farm, where the local site team leaves off, the control room picks up. And so they're really working as one team 24/7 around the clock.
And how many different power plants do a control room manage typically?
For small owners, it might be just a couple power plants. For larger owners that have a large suite, it could be 15, 30, or even beyond. Some of the OEMs are managing over 200, 300 power plants at once from one given location.
Wow. Okay. Let's say there is an emergency happening here. What could that be?
Yeah. An emergency could be a catastrophic failure with a unit. For any type of emergency, there's always some sort of protocol in place. There's always a chain of command to follow, someone to contact to initiate a response. Some of those responses could be remote in nature, just to do an investigation to see if it is a false alarm or if it is potentially something actually happening at the power plant. And so typically an operator would review the data that they have available to them and then make a determination if someone local needs to investigate and take an action there at the power plant.
And I guess once we're at offshore power plants, you need to be very careful of what kind of things you initiate, because it's pretty expensive to go out and check if there's an alarm wrong.
Yeah, it's very expensive to dispatch someone to a wind farm or solar farm, even if it is onshore. It's even more expensive when it's offshore. And so one of the main jobs as an operator in a control room is to try to reduce those in-person inspections and see what is possible to safely return the turbine to operation without causing additional harm. It's a very very tough balance to find, because on one hand you need to maximize generation to maximize the production of the wind farm and the income that's generating, but then at the same time you also need to look after the longevity of that equipment itself to make sure that it can reach its useful life that it's rated for.
What would be the consequences of not handling these cases well? It can be expensive to send someone out, but also what could be a major consequence?
Yeah, some consequences could be just continuing to reset faults. So just trying to really push the boundaries and what's possible in maximizing the generation of a wind turbine or inverter, whatever it may be. In those cases, pushing the limits of the equipment itself can lead to some sort of catastrophic failure. It could be a fire, it could be a turbine falling over. It could also even potentially be the safety of personnel on site. So there are some dire consequences with taking action.
So you need to balance the head-on overview, but also the eye for the details in all that data that you're looking at.
Yeah, you really need to single in on what's important in that situation and sift through the data points to find those necessary ones.
Now, when I prepared for this interview, I did a little bit of research, and I found this article from SCADA International, I think they called, that also highlights the importance of SCADA systems and the integration of data, this holistic network management in the control room. And that's also what we see here at SCADA International. We're so involved with the customer's needs when it comes to the control center. What role is it that the data acquisition and monitoring actually plays in the control room, would you say?
It's critical to have the communication to the wind farm so that data acquisition is paramount to the operations. And then also having that HMI that's clean, that's simple to use, that's intuitive for the operators, really saves them a lot of time, can save them a number of clicks and a number of keystrokes to taking an action. And so all of that can lead to more easier and informed decisions that the operator makes.
So the monitoring plays a massive part. What about the reporting and analysis part of it? I guess that also plays a significant
Yeah,
role.
the analysis really helps drive protocol changes and protocol development, understanding what trends are happening with operators. So they have a qualitative feedback piece to it, where operators are seeing hundreds of alarms potentially an hour and thousands throughout the week, and so they can share that feedback to drive changes in protocols. But the data actually is really essential, because then you can understand how successful certain reset types are, how successful certain actions are, and that can really drive the protocol development and advancement to more efficiently operating the wind farm.
Yeah. Now, you also talked about it before, but I guess it also has a lot to do with collaboration.
From a collaboration perspective, there's an internal and external perspective. From an external perspective, there could be inputs from a utility or a transmission operator, from a balancing authority, and so those communication lines are critical, because that has to do with the reliability of the power plant, the reliability of the local grid that the power plant's interacting with. From an internal perspective, there's different departments that can drive feedback into optimizing the operations of the control room and driving some of those protocols. So the site feedback from the observations from the boots on the ground is extremely critical in a piece of that, and then also from the engineering teams and technical support teams that also drive feedback when there are component failures. They can make modifications to those protocols to help drive better reliability in the actual machines themselves through some sort of protocol changes.
And how important is this coordination if a company wants to really succeed in the green energy transition?
Yeah, if a company wants to succeed in that transition, they really need to have all teams working in the same direction.
Yeah.
That's where the collaboration with the internal teams between engineering and technical support in the control room and the teams at the site is really critical. Mm-hmm. And so having regular sharing sessions, having situations where people from the field or from the engineering teams are actually joining the control room to understand their perspective of what they're handling. Those moments can be extremely defining in how successful a control room can be.
Yeah, that makes sense. I guess it makes sense in a lot of different circumstances and areas as well.
Yeah.
So the final question of the day: how does the control room of the future look like in your view? Yeah,
the control room of the future is efficient. It takes into account all of these different data pieces that are coming in, and there's a robotics and automation piece to it. So humans are never going to be fully removed from the control room, but the robotics are going to help the humans make faster and more informed decisions. So I see robotics taking over low-level control for simple alarms, for simple tasks that are happening. And then the operators are then free to do more advanced troubleshooting.
Yeah.
The systems will be providing suggestions for how to act, and then the operator can take that and decide based on the data that's being presented if that action is appropriate or if further action is required.
Well, thanks, Nick.
Yeah.
This was great.
Thank you.
Yeah.
It's wonderful to be here.
Yeah, and thank you to all the listeners.
Thanks for listening to the Energy Explained in Short series. If this episode was interesting, follow us and stay tuned for more to come in the future.